Good afternoon, everyone. My name is Oluwapelumi Aderemi, and today we'll be discussing topic architecting for the future, how microservices um, empower agile and high performance products. Um, During this session, we will be exploring um, the shift from monolithic architecture in designing software systems to microservices architecture. Uh, the reason why um, microservices have become uh, very prevalent in designing systems. Also talk about how we design the systems, how we build systems, how we scale software applications. Also look at some use cases to see the differences between monolithic architecture and microservices architecture. Uh, so by the end of the session, we'll have understanding of how to approach microservices. You have a deeper knowledge of the terminologies that are used and the uh, um, the perspective and the strategic perspective that thinking in developing systems that are scalable using microservices architecture. So when we talk about monolithic architecture, um, we are talking about a system for designing software that was used before microservices. Uh, when monolithic just stands for a system where all your code base, the business logic, database, data access, user interface are usually built into one single system. Uh, the problem around that is that it's difficult to scale such systems because they are uh, tightly coupled and every um, aspect, every component is um, dependent on the other one functioning. To explain better is like saying if one system is having a problem, it affects the whole system. If you need to change something, it affects the whole structure of your system. Uh, they were useful when applications were very simple and the demands were not very high. Whereas growing demands for most applications came about, they became a problem. You have a lot of downtime, a lot of problems, and deployment is also slow. You tell your customers or your users that there's going to be downtime because you have to scale something or do something on your server, which disrupts the user experience in general. So uh, just monolithic architecture is just when you bundle all your code together into one single unified code base. Uh, it's very fast to design that way, so that's why it was common as well. It was fast. You can easily build your system, test your system, and then you deploy everything at once. But if you have growing demands, it becomes a challenge using the monolithic architecture. uh, so this is an overview of the monolithic architecture. You can see the user interface um, connects directly with the business logic, data access layer, everything. And you have only one database managing the business logic, managing the data access. So if, say, for example, you uh, are having problems, uh, say, uh, with users signing up for um, your service, if you're going to fix that problem, usually in the monolithic architecture, you're going to have to change the whole business logic. Then you're going to redeploy again, and then that causes a lot of downtime and poor user experience for your users. So what's basically is microservices? Why are they different from monolithic architecture? They're independent services. That means all your components are developed as standalone um, services. They are loosely coupled and they are not dependent on each other to function. You're able to build um, a system where you have multiple services running. They can interact with each other using API communications and other communications depending on your uh, on the need of your application. Um, it's uh, each component, each service has its own database, so it does not have to rely on a database that is down or that is not able to service it at the particular time. So that makes fault isolation much easier. Remember the example I gave before. If you have a problem, say with your signing in on your system, on your service, you don't have to shut down your whole system. The other users that are already signed in or using the system can continue using your system. You don't shut down the whole system. You just fix the problem with that single service, and you are able to, and then you redeploy it, and then it goes back on. Does not affect the overall user experience uh, for your systems. So this is a diagram explaining the microservices, how microservices works in a high level um, uh, depiction. So the user basically sends a request to the through the API gateway, maybe request for to sign up. The sign up service can connect to any other service that it needs to connect to. It has its own database, so the user is able to uh, enter their details, their name, whatever you want, and then it has its own database. The signing function on its own also has its own database. It would, if the sign up database is down for any reason, the signing wants to has its own. Your product has its own database, so you're able to find you can see that it's really fine grained and like granular. Like you're able to uh, isolate problems. You can find where the fault is, fix that fault without actually affecting your whole system in general. So this is just an example. Say you have uh, uh, your e-commerce website running. Your client is on their device, their interface. They send a request for authentication, database with their details is able to authenticate them. They can find products. The product database is on its own. They make orders. If for whatever reason the products that has been selected or the database with the products is down, it's already passed to the order and it has its own database. They are able to continue processing their order. Saves you a lot of uh, uh, loss of revenue as a business. Also allows your users to enjoy their using your application. So basically, why do we need microservices? I've explained some of them. Uh, another Other ones include agility, aside scalability and resilience that I've already talked about. There's also technological freedom. Agility just basically is about faster delivery. If you have a system, for example, we'll see some examples of systems that grow rapidly. There are systems, the applications that need to deploy their code, need to deploy services every day. They are deploying thousands of services. What microservices helps you achieve is you can deploy very fast. You don't have to deploy all your services at once and then cause a downtime. You just keep on adding more services as needed to your application without causing any disruption whatsoever. Um, or the scalability helps you to scalability. You're able to add new features to your system without breaking it. If you want to add a new feature, say notifications to your e-commerce website, for example, you add that without having to break your application. They're resilient because you can isolate faults easily. Uh, 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 One failure does not affect the rest of the system. And technological freedom here just talks about you're able because you have these systems are developed independently and they're able to communicate with each other using APIs. You're able to use different technologies while developing. So you might, instead of using one um, programming language to design your own system, for example, if you need a particular language, if you find a particular language is better suited for a particular service, you're able to use that language and develop um, that service. You don't have to use the same programming language throughout. You're able to also um, get expertise from different people. So you have many people with different technical skills working on the same project, and that's what you can easily achieve using microservices. Can you might be able to do it in monolithic architecture, but it's quite difficult because everything is built together. So you usually find that those systems use one programming language, one technology, because it's you have to start finding ways to compile your code and it makes it slow. And it breaks things. Basically, you add something here, it breaks something somewhere else. So that's one of the benefits. And another reason why we use microservices for agility, scalability, and resilience. Um, so the microservice architecture is basically decentralized. That's the loosely um, coupled autonomous services that communicates, over protocols like say CTP, for messaging queues. The um, the every service that you have it has the has capability, of doing a specific thing and not affecting the and not relying or affecting the next service. And if it needs anything, you can request it. Uh, um, uh, then we also have independent databases. We don't have to rely on one database to store all our to retrieve all our data that will be used for our applications. You can release things if, say, for example, something is not ready yet. You can release things independently. You don't have to do it. Wait for let everybody be ready. Then we deploy at the same time. Can add a new feature. Your users can get that one before the next one is ready. Because if you have a monolithic system, for example, you'll probably be um, uh, trying to reduce downtime. So you want to wait. Let's get 5 services and 5 new features ready and deploy as one. But when you're using microservices, you don't have that problem. You can implement your features once they are ready. Uh, Also, the way microservices are, they are cloud native ready means that you're able to store them in containers. They are very loosely coupled and basically what that helps us do is that we are able to containerize our our services are. I'll talk more about containerization as we go on, but it just helps us manage our services um, uh, through the cloud using cloud uh, uh, services, cloud platforms like uh, AWS, for example, Google Cloud. We're able to take advantage of Docker containers and Kubernetes for management. So these are the core features of your microservices. We have autonomous teams. You don't wait for a team that's working on maybe the game function to a team that's working on setting notifications. Everybody works on their own. When you're ready, you review the code and then you push. You don't have to wait. Um, Communication using API. Yeah, you also find things like fault tolerance because you don't break your whole system at once, and service in independence. So some of the advantages include faster delivery, uh, easier scaling, improved reliability, and continuous delivery pipelines. Talk more about that. So some of the companies that use that use the I would say like kind of like made microservices very popular um, because of their business requirements. One of them is we have Netflix, Amazon, Spotify, Uber. Netflix is a big player in microservice architecture. They in 2009 they just got this rapid increase in users, and their monolithic system was not able to handle their requirements anymore. So they really thought about ways to serve their clients, and they have um, contributed massively into um, microservices. They um, they had a need for recommendations. You know, user data was growing, billing was growing. They needed better video encoding, and the structure that they had before was difficult to manage. Too much downtime. You don't want to go on Netflix and you're waiting for, or they say, oh, a service is down. Um, 2 hours you have to wait, or you have to wait 7 hours for to before you can watch a movie or do what you want to do on Netflix. So to reduce that, they needed a system that was a robust system that was loosely coupled where they can handle things independently. They don't need to make users wait, or in trying to scale the application, they were able to scale massively and build proper fault tolerance in their systems. We also have, like I mentioned, Amazon. They are also a monolithic system. There you find, as they were growing, there was a lot of problems. A lot of problems that came about, like programmers were like stepping on each other's code, for example. So they had to also um, adopt microservices, and they are a big player as well there, especially in cloud native services. They have the AWS system that helps us to use take advantage of elastic containers, um, uh, um, uh, various types of databases for storing different kinds of data as well. So uh, microservices are not without any challenge. They're very powerful, as we have already seen, but they can become very complex. You can see a very simple um, beginning, and then it can become really complex where there's so much to manage. So you may need more people to manage those problems, but the advantages still outweigh the disadvantage. The good thing is, like, if there's a problem, you can identify that problem and fix that problem, and doesn't affect the whole system. So it can become really complex to understand if not properly designed as well. Um, uh, Another thing is data consistency, because every um, uh, uh, service is managing its own database. Basically, if say developer one uses a certain type of schema or data flow, he has to think of how it's going to affect the next uh, the other person, the other services that already have databases, and how they're going to communicate. And that's something you have to always take into consideration. It's also orchestration, needs to orchestrate properly, and then also latency. Sometimes you might have downtime, so you have to also um, think about that. Basically, it also comes with orchestration, how you orchestrate properly, and how you plan um, for problems in the future, such as latency. You might have your database is currently down, for example. So if your database is currently down, what are you going to do? For example, say you're calling, you want to authorize somebody, but you can't get that data immediately. How do you undo that? And also things like security. Also, you have to plan for such. Um, there's also you have to something that helps with the challenges is observability. Um, you you need to be able to monitor your systems, to track your systems, to log problems so that you can fix them quickly. And there are tools for doing that. We'll see them as we go on. Let's quickly look at some use cases here. So we have an e-commerce application. It has various services that needs to run, and we need independent scaling, faster iteration. If we build that system, for example, using a monolithic setup, the entire system, from the product catalog to shopping carts, the order management, the payment system, everything is built into one business logic. You have to deploy everything at the same time. Now, if you need to make any change to any of that, any of those services, you need to redeploy the whole system again. That causes downtime. It's not scalable. You can add a new feature without stopping everything. But when you move to say microservices here again, so the client makes an API request, to say the product service that has its own database. He has an item to his cart. He has left the product service. He's no longer using that. Any problems with that does not affect his own. It does not affect his flow anymore. He has his database. He makes another request again to maybe the payment service. Is going to need does not he does not need to rely on any uh, problems that might have happened in any of the previous phases. If, for example, you want to add um, a new payment service, for example, you you don't have as in you don't have to stop um, your users from paying with the services that already exist. You can easily create a new payment service without disrupting the flow. You add a new payment method, and then when it's ready, you deploy it. Users can see it and use it. You don't lose any money in the process. Um, Another example here is health care system. I use an application I recently worked on. Um, it's the application Talk Terra basically allows user patients communicates with therapists. Basically, um, patients are able to schedule appointments. They are also able to share their medical records from the NHS, and then the therapists are able to see their details, able to confirm, and also have video sessions um, with clients. So if we have built that system, for example, using monolithic architecture, we'll have everything again coupled into one um, one system. Now imagine if uh, there's a problem, for example, medical records um, needs to be updated. You need to wait. Your whole system has to stop. Imagine you're already having video sessions already. You have to alt everybody's process at that time. It's not um, it's not good for user experience. Yeah. So that's why we have to think about using microservices to build the application. So basically, the patients, we have everything really coupled, having its own database, having its own business logic in its own container. Basically, if you need to update any of the services, you can uh, do so without affecting the whole application. And then there were multiple developers that worked on the application. Uh, we were able to use the appropriate programming technology languages that um, are for developing different services. We went for Node.js, for example, for video communication because we felt that that was the best. That will give us proper um, that will help our users have a seamless experience using the application. So different developers development teams were able to work with their technology, with their tech stack, basically on the project. So some common misconceptions or confusions might be between monolithic application and monolith microservice and what an API. Some people think that APIs are microservices, but they're not the same. As I've already explained, the monolith is one big application that is tightly coupled together, while we have microservices. We have many small applications running and then communicating. That's why we have APIs. APIs are just communication layer. They help services communicate with each other. So APIs, not microservices. Um, they're just one of the components that help microservices. Um, we'll see more about APIs here, their communication layer. So, so APIs in microservices, most times you'll be using REST APIs or GraphQL for most of your um, communication needs in uh, microservices. The API, I believe, they are the backbone of microservice communication. It does define how a service talks to the next one. You know, your REST APIs, um, your get, your put, your push, basically just asking this. For example, you need to get data from your database, you use a get request. That's what your REST APIs are basically. Um, so there are two types that you see, synchronous and asynchronous. So mostly synchronous APIs, you will use things like REST and your GraphQL. You're using direct calls, your push, and all of that. Your push, your get, and the other REST verbs. So you also have asynchronous messaging, for example, when you're doing calls, when you're doing communication that you don't want to wait for um response, like it's like kind of like the fluid communication. You use things like um use RabbitMQ, use Kafka for asynchronous APIs. Um, so you also have loose coupling, and then you have API gateway routine. So API gateway routine is just telling um is it's it's like, okay, you have one API gateway that finds the other services for you. So you're not making, so you don't have to write like so many APIs basically. So in many systems, the API gateway sits at the front of routing external requests basically. So they just approach, they just send your request to the right service basically. So you're not going to be saying every part of your code say, oh, you go um go here, go here, go here. The API gateway is going to do that for you. It also makes your code a little bit secure. If for example your system is um uh your system is uh hacked, for example, if there's a penetration into your system, they're not able to really know the APIs to maliciously attack them directly, because they only see the API gateway in your code anyways. So that's just one way of adding security to um uh microservices. We have various design patterns in microservices. One is using your API gateway. Um, like I mentioned, start as like your single entry points for all your client requests, and they help you to handle your routing to different services, basically. We also have service discovery pattern. Sometimes you're able to combine them. You have your service discovery, then it helps you also with your API gateway, also finding different services. You're able to combine them if you want, if you so wish to do so. Um, so we have a circuit breaker pattern. It just prevents failures from trickling down, you know, cascading failures, by temporary halting calls. For example, if a call is constantly causing, it's constantly failing the service, it's constantly causing a problem in your service. We have something like Netflix Asterix. It's famous for implementing circuit breaking. It stops that call from breaking your own system, basically. Um, we also have CQRS, that's event sourcing. It helps manage data consistency. When you're having real-time updates in complex systems, just make sure that you just helps you make sure that data that you are uh, adding stay consistent. The workflows are the data flows are able to interact as required. So some of the pitfalls of microservices will include over fragmentation. This is just like when you are overusing uh, the advantage of microservices here. You're just creating services for the sake of creating services. Remember, it can become cumbersome, it can become very complex quickly. So you look at the size of your team. You're not creating a service just for the sake of creating a service. You need that service. It's it's best to create that service on its own, just integrated with one that's already existing, so that you don't have um too much services that you cannot um handle. So sometimes people design microservices wrongly. They share databases. That's not um, in the spirit of microservice architecture, because we want things to be loosely coupled. We don't want things. Um, we don't want one system. We don't want two systems or three systems sharing the same database. They might be using the same data, but because that database can be corrupt, that database might be down, it might be faulty, might get um, probably maybe deleted or for any reason, it affects your whole system, and then it just defeats the purpose of microservices. So when you're creating a microservice, you have to think about the data structure, think about the data flow as well. Um, so sometimes, like I mentioned, there's monitoring for your microservices. You have for observability. If you don't set up your microservice to be monitored correctly for logging and uh, for logging faults, for monitoring their performances um, across your across the deployment, you will not find the problems quickly. You will be able to tackle them quickly as well. So you need to use services that uh, already exist to help you in finding faults before they um, basically before they exist. Some of the best practices um, for designing uh, microservices is don't um, build services that you don't need. We have DDD uh, boundaries. We have API versioning. Basically, is uh, making sure your APIs are, are regularly updated. You're you're keeping track of each API you're developing. As services evolve, the older clients should continue to function, without breaking automatically or breaking unexpectedly. So you have to keep on watching for your APIs. You also have to invest in observability tools, like for metrics, for tracing, for structured logs to help you find faults in your system. Implementation components for microservices. We have service registry. This is where you register each service on your service register. Then you have your API gateway. Once they have been registered, your API gateway is able to find them. Is able to find them easily, and then you have load balancing. Load balancing is basically uh, when a system needs to say increase in the capacity, that is in its efficiency. A load balancer is just going to help you, distribute incoming traffics, to more multiple service instances. Say you just help you create a new instance, and then you distribute more traffic to that place. And then also, once the service is no longer needing all of that, it's not having too much traffic, it closes those services as well. You also have your CI/CD pipelines. What those do is it just stands for continuous integration, continuous deployment or delivery. Uh, it's basically a set of practices for streamlining development life cycle. So you're able to integrate code into your services and deploy them quickly. You're able to also do versioning. So it stays consistent. It's also you don't have to stop or a service before you're able to like implement a new um, structure to the code or to add a new feature to it. Um, and you also have uh, monitoring and tracing, like I mentioned, observing your services as they work, you know, checking for security, making sure that the service registry is updated. It's saying that you're able to see when a service is down or is faulty. You're also able to find um, the cause of the problem using logging. Basically, it's just an overview of microservice implementation. You have your services that are registered for service discovery. So user makes a call. The API gateway is able to find that service on the discovery register, then is able to send it to the right location. You have your CI/CD channels that are able to push code um, on the fly. You have your load balancer sending traffic to new services and closing them. They are not required, saving you money, saving you um, just keeping your system efficient. Only what is required is being uh, used. We have monitoring, and we have security, and we have microservices come together. So we look at some of the tools that are used for microservices. We have Docker. Docker is just a containerization tool that is used to um, package your service for for deployment to a cloud, to a virtual machine, or to say you want to put on the cloud, for example. So it just provides containerization facility that allows microservices to run in isolation. Basically, it's like you've written your service, put it in a container, and all the dependencies that it needs to work on a new system is given to it, and you're able to say combine it with Kubernetes, for example. Um, so basically, this is an overview of Docker. It's a microservice. You put the dependencies that are required in a container, then you push it to say Kubernetes, for example. Um, your Kubernetes is basically for orchestration, so or your orchestration layer. It helps you to manage. It helps you to manage your containers. It helps you to manage the life cycle. Ensures that it is always available. It can scale when it needs to, when it needs to on demand. It also integrates natively with service discovery, with load balancers. Kubernetes basically is a is where your containers live, and then it helps manage the life cycle, make sure that it's working basically. And then also integrates very well with cloud services as well. So your containers are going to be put inside of a pod, and that pod will be on a node. So that's the workflow for Kubernetes. Basically, the pod is the smallest deployable unit in any cluster. So uh, we have Docker for the containers. We have Kubernetes for orchestration. Um, and there's Kafka, like I mentioned before, is for communication. For distributed messaging systems, when you have when you need your service requires asynchronous communication, streaming, and you don't want, and you need it decoupling between services. We use Kafka. It's ideal for systems that require real-time data processing. Um, And we also have Prometheus and Grafana. These are visualization tools. Basically, Prometheus collects the metrics, collects your from your microservices, um, how they are performing, and then Grafana is just visualizing this metrics on dashboards and graphs, basically. So they enable continuous observability. Um, you're able to plan ahead. You're able to see your capacity as well. Uh, we also have ELK stacks, as Elastic Search, your Logstash, Kibana. They provide centralized login indexing, and you're able to search um, for things easily. Able to search um, your for large volumes of logs in your application using your Elasticsearch. Modern trends. Uh, um, Microservices have become very prevalent in today's development uh, architecture for um, building services that are scalable, that are agile, that are reliable, able to do fault isolation. However, in technology, things are always moving quickly. We also seen the emergence um, uh, of different architectures again for solving specific problems. We have uh, your serverless, we have micro front ends, we have service meshes, we have AI ops, uh, automation as well. Basically, the key takeaways from this session that we need to design for the future. You need to design thinking that your system is going to require um, new features in the future. So that's why you have to you have to think about using microservices rather than building monolithic applications, except you are 100% sure that that system needs to be monolithic. You don't need to go down that route. You need to try to build systems that are scalable. Think of the future. You're able to add more services. You know, um, focus on on building microservices that are stable, following the best practices. Don't build services for the sake of building them. Try to make sure you're able to observe your system as it's functioning, the containers, your services, and all of that. Um, and whenever you can automate things, just do that so that you don't, for example, your CI/CD pipelines, create them so you're able to push your new uh, code easily. Also look at some clear API contracts. That's how are you building your API? Are we using REST here? Why are we using it? Um, Also about your database. Your databases, you have to find the proper workflow to make sure they're able to communicate and continue to monitor them. So in conclusion, microservices help us to build systems that are agile, scalable. It helps also to manage DevOps. It also helps us to build systems using proper tech stack that we need um, to use, and also uh, the evolving architectural landscape. Businesses needing new features that they did not plan for, or they find new things that will help their system grow. They're going to need them, and then you've already thought about that from the start, and you've used a proper architecture that can handle it without any faults. Um, so, thank you for listening.